So yeah, like once again, I will welcome you. So let's start our today's sessions, which is designing Azure Compute applications, hosting and infrastructure solutions. Okay. So before we begin the today's sessions, let's quickly recap what we learned in our previous session. Okay. So in our last topic, we focused on the business continuity, Azure backup, again DR, that is the disaster recovery. And we also cover the in depth of all that, like business continuity planning, BPC, disaster recovery, DR, recovery time objective RTO, recovery point objective RPO, and Azure backup, recovery service vault, Azure site recovery, recovery plus, active passive architecture, active architecture, and business impact analysis. Okay, so most importantly, we learned that ability keeps applications running and disaster recovery restored the applications when the failure occurs. Okay, so now we move into the another major AZ-305 domain, okay, which is designing Azure Compute solution. So after designing the identity, security, storage, business continuity, so we must determine where will be the applications actually runs. Okay, so this is one of the most important architectural decisions in Azure. So, so So another question arises, why the today topics matter. So imagine a company wants to deploy, okay, a legacy .NET applications, okay, and then a containerized microservice platform, then a global e-commerce website, okay, then a high performance enterprise application. So we should use the Azure Virtual Machine or Azure App Services or Azure Kubernetes Services or Azure Container Apps or Azure Functions. So the answer depends upon entirely like business requirement, architecture's goal, scalability requirement, cost strain, operations capabilities. So choosing the wrong compute platform can result in higher cost, poor scalability, increased operational complexity, okay, and security challenges and technical. Okay, so as an cloud architect or Azure cloud architect, our primary responsibility is selecting the correct compute platform. Okay, so what will be the today learning objectives. By end of this sessions, we will able to see, understand the Azure Compute Services, okay, design VM based architectures, understand the Azure Virtual Machine design, evaluate the compute hosting options, design the scalable infrastructure solutions, and understand the scalability sets and ability zones, and also look for the how to apply the architecture level compute decision framework and look for the how to prepare for AZ-305 compute related question answers. Okay, so let's start with the first subtopic, which is designing Azure Virtual Machine Architect. Okay, so before we explore the container, okay, app services or the serverless computing, we must understand first, like Azure's most fundamental compute service is Azure Virtual Machine. Okay, as we all know
Sorry,
that.
can you enlarge the picture, please?
Okay, so what
Yeah.
I'm telling, before we explore the container, app services or serverless computing, we must understand Azure's most fundamental compute service, which is Azure Virtual Machine. Okay, so many Azure services extract the infrastructures away, but virtual machine do not. So virtual machine provide maximum control and flexibility. Okay, so imagine an organizations want to migrate an existing applications to the Azure. Okay, so what will be your current environment? So it would be like let me write here in chat. You have also the okay. So current environment would be like Windows Server. Okay, then IIS, then .NET, application, then SQL connectivity. Okay. So the application has a complex dependency, custom software, legacy integrations. Okay. So rewriting the application is not a feasible. Okay.
Okay.
Organizations need infrastructure similar to on-premises. Okay.
Okay.
So this is where the Azure Virtual Machine or any virtual machine for any cloud becomes a strong architecture choice. Okay. So before going, before looking the what is the Azure Virtual Machine, let's see what is the compute decision framework. So if we see on my screen, so here choosing the right service is like architecturing an Azure begin with the selecting the optimal compute model based on control,
Yeah.
cost,
Cost.
complexity. Okay, which has three things, no, four things. IaaS, which is infrastructure as service, and
Services.
VMS, it means virtual machines comes under the IaaS. Okay, virtual
Okay.
machine is comes under the infrastructure as service, which provide
Okay.
the maximum control, legacy, migrations, custom OS requirement. Okay, whatever you want. If you want to install Windows, so you can install Windows. If you want to install Ubuntu, you can install Ubuntu. So it's depend upon your requirement. Okay.
Mm,
Now here is PaaS. And what is PaaS? Do you know what is PaaS? Can you tell me what is PaaS? Its definitions. What is PaaS? Any idea?
platform as a service.
Exactly. So platform as a service, PaaS means platform as a service, which include the app services, which manage the hosting, focus on the code and automatic scaling.
Mm.
Okay. And what is container? So your AKS, ACI, EKS. Okay. Like this AKS is what is AKS? It is the Azure Kubernetes service, the service from the Azure. Just like that, there is GKS. What is GKS? So GKS is Google Kubernetes service. It is a service from the Google. And what is EKS? EKS is Elastic. EKS is like EKS is from Amazon. Okay, Elastic Kubernetes service.
So you know what? You know the pass, yeah,
Yeah,
is for set platforms like Azure, AWS, GCP.
yeah. So it's all have
Because
all have IaaS, PaaS, and SaaS. Okay. So in
yes,
so yeah,
because I've been
exactly.
on pass
Yeah,
before. I've been on pass project before. So yeah,
yeah,
GCP.
exactly.
It's
So
okay.
okay,
Yeah.
let me give you some root definitions. So look, all cloud are same. Okay, all cloud are same
Yeah,
with
absolutely.
different service name. In Azure
Yeah,
we say
absolutely.
Azure Kubernetes service. In Azure we say
Mm.
virtual machine. In Azure we say VNet, virtual network. But the same case with Amazon, we say EC2.
Mm.
Okay,
Okay.
virtual machine.
Yeah.
Their name of virtual machine EC2. We called VPC, virtual private. Okay, then we call EKS, which is replica or which is similar to AKS in Azure. So
Okay.
long story short, all cloud are same with different service name.
Yeah, absolutely.
Okay,
Absolutely. Yeah.
so don't confuse. Like if you have a
I
knowledge
know,
of,
I know, I know.
yeah, so yeah, exactly. So you have a knowledge of one cloud, so
Yeah.
you automatically you are the multi clouder. Okay,
Yeah.
so yeah, so now let's start. What is Azure Virtual Machine? Okay, okay. So an Azure Virtual Machine, which is VM, is an infrastructure as a service. Okay, IaaS offering that's provide a fully managed virtual server running inside the Azure. Let me write here the definition. So you have
Mhm.
Azure. virtual machine. Okay, in short we call VM or VM or VMS. Okay,
Mm.
so it means an Azure VM is an infrastructure as a
Service.
service, which is IaaS,
I don't know that one. Yes. Yeah.
offering that provides what? A fully managed virtual server
Control. Nice. Okay.
running inside the
Okay.
Azure or cloud. Okay,
Okay. Yeah. Yeah.
or any
Mm.
any cloud. Okay,
Yeah.
so
Yep.
yeah, so Azure manage the physical hardware, data center infrastructures, hypervisor platform, and the customer manage the operating system, applications, middleware, security configuration. So why do we need a virtual machine? So not every workload can be modernized immediately. Okay, example,
Okay.
legacy applications, older enterprise software, custom applications has a
Okay.
specialized workload, third party software, a vendor supported systems. Okay, and a specialized operating system has custom configuration. So virtual machines provide the maximum flexibility. Okay, so what will be the real world scenario? So imagine a multinational insurance company. Okay, they operate a claim processing system, and their requirement is Windows Server, customer middleware, vendor supported software, specific OS configurations, and they are migrating to the container and the app services. Would require the extensive redesign. Okay,
Okay.
so architecture recommendation is Azure Virtual Machine or Virtual Machine. This allow rapid migrations while minimizing the applications changes. Okay, and
Mm.
what is the Azure VM architectures? So let me write the simple flow of. Okay, so VM basic architecture flow will be your first is application, then operating system, then virtual machine, then Azure host infrastructure. Okay, and what are the
Yeah.
core component of the Azure virtual machine? So component one will be your virtual machine, the compute resource, for example, Windows Server or Linux server. Okay, component two will be your operating system disk, which contains the operating system or boot file. Just like component three is data disk, which is stored the application data, logs or databases. Component four will be your network interface, that is NIC, which provide the network connectivity. Okay, and component five will be your virtual network, which connect the VM to the Azure infrastructures. So Azure virtual machine architecture diagram will be like, let me write here also, Azure VM architecture diagram flow will be like, first start with virtual network, then it goes to network interface, then virtual machine, Okay, and
Mm.
virtual machine has OS, disk, and data disk. Okay,
Mhm.
so what? So component. So there is component like virtual network provide the network continuity. Network interface connect the VM to the network. Virtual machine host operating system. OSDX boot operating system. Data disk store the business data. Okay. So what will be the step-by-step request flow? So let's examine how the user access the virtual hosted application. So step one will be your user send a request. Step two will be traffic enter the Azure network. Step three will be traffic reaches to the virtual machine NIC. Okay, which is virtual. Then step 4 will be the operating system process request. Then step 5 will be applications response. Step 6 will be your response return to the user. Okay. And what will the VM sizing concept? So one of the most important Azure architecture topic. Okay. Azure provides many VM families. Architect must choose the correct one. Okay. We should not
Yeah.
choose anyone. We should choose the correct one.
Okay.
So what will be the general purpose? Okay. So if we need the general purpose users which is balanced, so we look the balance which has a CPU and memory. For example, like B series or D series. Okay, use case will be like application servers or web server. And what will be the compute optimized, which has a high CPU. For example, F series. Okay, and what will be the use
Mhm.
cases? So batch processing, compute intensive workload. Okay, and what will be the memory optimized? So in that case, we need the high RAM. Example, E series of
Mm.
RAM, M series of RAM. Okay,
Okay.
and what will be
Mm.
the use cases? So use cases will be your databases, SAP workload. Okay, and what will be the optimized?
Mm.
Storage optimized. So storage optimized looks for the high disk throughput. Okay, for example, storage uh, focus VM families. Correct. So
Mm.
GPU and what will be the GPU optimized? So it designed for AI, machine learning, or rendering. Okay. So architecture decision framework will be like in that case where the architect should evaluate the CPU requirement, memory requirement, storage requirement, okay, network throughput, cost constraints, scalability requirements. Okay, so
Mm.
these are decision framework which is taken by
Okay.
architect. Okay,
Okay.
so what will be the ability set? So one of the most important VM resiliency topic. Okay, let's imagine there is a simple single VM, and if the host fail, application will be down. Okay, it is just like when you can't access your laptop, you can't access the Azure, Amazon website on it. So in
Mm.
that case, like your your VM is your like MacBook, and your application will be your
Okay.
Amazon. So if you can't open your MacBook, suppose a MacBook is your VM. So if it's fail, so you can't access your applications. Okay, so it's very simple. So think this on a large scale. Okay, where the Amazon applications are hosted on the server, VM server. So if that VM got fails, you can't when you type the https www.amazon.com, so you see the error 404. You can't connect with them because their server are failed. So these are important in the evaluation set for the Azure architecture. Okay. So now
Mm.
what will be the fault domain? So protect against the rack failures, power failures, hardware failures, and which also update the domains. Okay, like project against the plant maintenance events. Azure update the host in stages. Okay, So what will the security considerations? So architects should implement the NSG, just-in-time VM access, Microsoft Defender for cloud, disk encryptions, manage identity, private networking. Okay, and what will be the governance considerations? The organizations should define the approved VM sizes, OS standard, tagging policy, backup requirement. Governance prevent the VM, okay, spiral. And what will the scalability considerations? So virtual machines can scale the vertically, horizontally. However, manual scaling introduce the operations overhead. So we will address the large scale VM architecture later. Okay. So what will be the high availability considerations? So single virtual architect should generally be avoided for the production's workload. So architects should be use the ability set, availability zone, and load balancer depending upon the requirement.
Mm.
Okay. And
Mm.
what will be the DR considerations? So projects project VM using the Azure backup, Azure site recovery, recovery planning remains critical. And what will be the cost optimization considerations? So common optimizations technique will be right size VM, reserve instances, Azure hybrid benefits, and auto shutdown for the non productions workload. So many organizations overspend due to the oversized VM. And what will be the monitoring
Okay.
considerations? So monitoring considerations will include your CPU utilization, memory utilizations, disk throughput, okay, network
Mm.
throughput, and availability metrics, and monitoring support optimizations and reliability. And what are the common mistakes people do? So oversize the VM, single VM production deployment, no backup strategy, no DR plan, public IP exposure, ignoring the monitoring, improper the VM family sections. And what will be the best practices? So best practices will be choose a VM family based on workload. Okay, like right
Okay.
size resource says use ability sets. Okay, implement the security control, monitoring continuously, backup the critical workload, and plan for your recovery. Okay, so let's take a AZ-305 exam perspective. So very common in exam, which may ask. So scenario one. Let's take scenario one. So a legacy applications require full OS control. So answer will be your Azure Virtual Machine. And if the question asks applications require custom middleware installations, then also answer will be your VM, Azure VM. And if
Okay.
the scenario will be Azure production workload require the protection from the host's failure, so answer will be ability set. Okay. And if the scenario will be
This will be what? Sorry, I didn't hear that.
yo
What would that be?
okay, so if production's workload requires protection from
Okay.
host failure, then answer will be
Yeah.
ability set. Okay.
Okay.
And if the database workload require high memory capacity, then your answer will be always memory optimized virtual machine.
Okay.
Okay. So now we are moving to the next subtopic, which is designing ability set, ability zone, load balancer, and high available VM architectures. So what we learned in our just now in previous topic. So we learned how virtual machine provide the full OS control, infrastructure flexibility, legacy workload support, custom applications hostings. So, however, one major challenge remains. Imagine your production applications run on single VM. Okay, what happen if
Mm.
the physical host fails? What happen if the racks lose power? What happen if the Azure maintenance occurs? And what happen the data
Mm.
center experience issues? So, your answer is simple: applications down. Okay, so for enterprise workload this is unacceptable, and this is why you as an architect must design for high ability. Okay, so imagine a global insurance company and their claim applications process 1,000, or let's suppose 10,000 claim per hour. Okay, and the application is hosted on one virtual machine. Okay,
Yeah.
and suddenly host fail. Let me write here. So suppose a global insurance company which has
So now
10,000.
we need to sorry. So now we need to put into
Mhm.
consideration that system can survive failure,
Exactly,
and also
exactly.
the one that you just said now, the I
Ability.
yeah, yeah.
Yeah,
Okay. So those are very key.
yeah. So so
Okay.
10,000 claim per hour application is hosted on single VM.
Mm,
Okay, single
mm,
VM, and
mm.
suddenly
So
host failure.
mm.
Okay,
Yep.
then what will be happen in that case? In that case, the entire application become unavailable. Okay,
Okay.
which impact the business
Absolutely.
like lost productivity. The
Mm-hmm.
main thing, customer dissatisfactions. If you can't
Absolutely.
satisfy your customer, they will go
Customers, yeah,
from you to your another company, or
absolutely.
you they go to your like competitor. Okay,
Absolutely.
so you and that in that way you have a financial losses. Okay,
Absolutely.
so your goal, or I am saying like architecture goal, because you are going to be architect.
Mm.
So your goal is to timeline the single point of failure.
We have my architect one.
Okay, so now what is high ability? So high ability is referred to designing the system that remain the operation despite the failure. Okay, if you
High availability, yeah?
yeah, high ability.
Yeah, high
So
availability.
what is high
Yes, okay, I
ability?
heard you
So
right.
it has two things, set and zones. Okay, and what is the definition of high
Yeah,
ability? So high ability refers to designing system that remain operational despite the failure, and the goal is failure occurs, application continue, rather than the failure occurs, application stop. Okay, so
yeah,
why? So
okay.
if you see, it has two things, ability sets and ability zones. So what is in ability sets? So in ability sets, hardware isolation, the same data center protect against the hardware failures and plan maintenance by disturbing the VMs across the fault domain like power network, and update the domain B routes, and its SLA is 99.995%. Okay, and
Yeah,
if you see ability zones, so data center isolation is the same reason, and which protect against the entire data center failures. Zones are physical separate locations with an Azure region, each with dependent power, cooling, and networking, and its SLA will be 99.99%. Okay,
uh-huh.
so you can't run it from here. Okay, so why do we need
Okay.
high availability? Because failure are inevitable. Example, hardware failure,
Absolutely.
power failure,
Mm.
host failure,
Videos,
plant
yeah.
maintenance, or ability zone failure.
Mm.
So architecture or you design system expecting the failure to occur. Okay, feel
Okay.
feel like you are a tech and think like that, understand like that. Okay, then you like enjoy to learn everything. Okay, so that's why
Yeah.
I'm telling,
I'm trying
yeah,
to, I'm trying
exactly,
to,
that's why I'm
I'm trying to.
calling that you have a responsibility to design a system expecting failure to occur, because you are going to be a tech. Okay, yeah. So what is the
No.
Azure ability architect? So Azure architect, so in Azure ability architects, Azure provide the multiple layers of the resiliency. Okay, What is that?
Okay.
So let me write in chat. So you have your
Mm.
note. So it has
Yeah.
ability sets, then ability availability zone. So are you enjoying or not? And regional architecture. Okay. So each protect against the different
Okay.
failure scenario. Okay.
Ah,
So what is
okay.
ability sets? So let
Depending on their set, yeah.
yeah. So what is ability sets? We already covered that. So let's revise ability
Yeah,
sets.
hardware isolation. Yeah, same data center.
Yeah. So ability sets protect against the fault domain and update domain within the data center. Okay.
Yeah,
And a fault domain represents a shared power source.
same region.
Okay. Shared network switch and shared rack infrastructures. Okay.
Okay.
And what is default domain and what is a update domain? So Azure particularly perform the maintenance without update domain, which is like your VM1, VM2, VM3, VM4, and so on. Okay. So all may reboot simultaneously, application outage occurs. So with update domain, UD1 goes to VM1. Okay, UD2, which is update domain 2, goes to virtual machine 2. UD3 goes to VM3. So Azure updates one domain at a time and applications remain available.
Okay.
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 And what is the limitation of the ability sets? So ability sets operates within a single data center. They do not protect against the data center failure, zone failure, or region outage. This is where the ability zone becomes important after ability sets.
Okay.
So what are the
Okay.
ability sets? Sorry, ability zones. So ability zones
Zones.
are physical separate data center within the same Azure regions, and each zone has
Region. Okay.
independent power, independent cooling,
Traffic
independent networking.
and networking.
Okay,
Mm.
and like
Yep.
it has a architecture flow will be like, suppose one region has,
How about the regional
yeah,
architecture?
exactly, one region has multiple zone like zone 1, zone 2, zone 3. Region
Okay.
2 has a its own zone, 1, 2, 3, 4, 5, anything.
Okay.
So why
Regional
ability zones
architecture.
matters? So imagine a zone 1 experience a power failure where the applications in zone 2 and zone 3 and remains operational. So this provides this significantly higher ability than the ability sets. Okay. So what
Yep.
will be the ability zone architecture? So zone 1 goes to VM1, zone 2 goes to VM2, zone 3 goes to
Into.
VM3, and so on.
Mm.
So if one
Yep.
zone fails, remaining zones continue surviving the traffic. Okay.
Okay, okay,
So let's
okay,
take the
okay.
AZ.
So zone
Yeah, tell.
zone two cannot affect zone one, yeah? VM1 cannot affect VM2. Is that what you're saying?
No, it means if one zone fails, suppose
Mm.
one zone fails, so in that case,
Yeah.
one zone is connected to the virtual machine one. So in that case, only one virtual machine is gonna fail. So remaining zones continue the serving the traffic. So zone
Absolutely.
two,
Okay.
zone three, zone four,
Okay.
and so on has a,
Okay.
because that are
Okay.
not disturbed, so that are continue to like
Absolutely.
serving
Okay.
you. Okay. So
I
yeah,
get you. That's
yeah.
fine. Yeah.
So now take the AZ-305 exam tips, some of the exam tips, okay, which is very common for your exam or in interview also. So application, suppose a requirement is application must survive the data center failure. Okay. So
Mm.
correct answer will be ability zones, not ability sets.
Yeah.
Okay.
Okay. Okay.
Now, what is load balancer attack flow? So high ability requires more than multiple VMs. User needs a way to access the healthy instance automatically. So this is the role of the Azure load balancer. Okay.
Yes.
Huh,
Can you expand that? Okay. Like, let me see.
okay. So what is the Azure load balancer? Okay. What is the Azure load balancer? So Azure load balancer distribute the traffic across the multiple backend resource. Okay.
Okay.
So
Okay.
it's, let me type here, load
Okay.
balancer archi architect flow will be look like user traffic goes to load balancer, then goes to like one
So, okay. So
VM1,
this is for infrastructure as a service, yeah?
VM what? VM3.
This is for scalable
Yeah,
IaaS.
exactly. Yeah.
Yeah. Okay.
So, and why do we need load balancer? So without load balancer, user has only one VM. So if one VM fails, application unavailable. With load balancer, user had load
So,
balancer and load balancer has multiple VM. So if VM1 fails,
yeah.
traffic automatically route to the VM2. Okay.
So,
And
yeah.
what is a health probe? So one of the most important load balancer concept. Load balancer continuously check the HTTP, HTTPS, TCP. Okay, endpoint health. For example, VM1 is healthy, VM2 is healthy, VM3 is unhealthy. So traffic sent only to the healthy VM, not to the unhealthy, because if the traffic
Yeah.
goes to the unhealthy,
VM2.
it
Okay.
can't work. Like it's useless. Okay.
Okay. So,
Yeah, tell me.
well, it was
Yeah.
fine.
So what will be the benefit? So benefit will be your host failure protections, zone failure protection, automatic traffic distribution, and improve uptime. So yeah, so let's continue with the next topic, which is the design virtual machine scale set, VMSS, and auto scaling and elastic compute architect. Okay, so
Yeah.
just before we learn how to build high ability VM architect using the ability sets, ability zone, load balancer, and health probe. So these designs solve one of the major challenges like ability. Okay, like however another challenge remain, imagine your application's normal servers has a 5,000 users, but during the seasonal events it's become 50,000 users, so arrives within a minute. So what happened, your high available architect may fail because it cannot scale. So this is where the Azure architecture must design for elastic scalability. Okay,
Okay.
so
Yeah.
now what is the virtual machine scale set, which is VMMS? Okay, so if you see here,
It allows you to create a group of
yeah,
identical
so VMS
non-based
allow you
VMs.
to create and manage a group of identical load balancer virtual machine.
Based
The
VMs.
number
Yeah.
of virtual machine instance can automatically increase or decrease in response to demand or define the schedule,
Demand.
which is auto
Yeah.
scaling based on the matrices CPU memory or schedules. High availability
Yeah.
integrates with the
High
availability
availability
zones. Okay, and
and
management
management.
update OS image across the entire set
Images.
seamlessly. Okay, so if I
Yep.
break into very simple way, so Azure Virtual Machine scale set allow a tech to deploy and manage the multiple identical virtual machine as a single source. Okay, and why do we need VMSS? So without VMS, administrator create VM. Okay, which is operationally complex. With VMSS, it's will be a scale set, then it's go to the automatically create VM as needed. Okay, let me write here so you can't be confused. So without VMSS. Okay,
Mm.
admin create VM, then VM, then VM, then VM, then VM, and so on. Okay, which is operationally complex. Okay, so here come VMSS. So with VMSS, we apply the skill set, then it goes to automatically creates VM as needed. Okay, so which is much
Okay.
simpler and more scalable. Okay,
Okay.
so now what is auto scaling? So auto scaling allows Azure to automatically adjust the capacity based on the demand. Okay, instead of the fixed capacity. So Azure dynamically adjust the resource. And why do we need auto scaling? So traffic patterns are unpredictable. Okay, for example, 8 a.m. 20% CPU, 12 p.m. 60% CPU, 2 p.m. 95% CPU. So without scaling, application becomes slow, and with auto scaling, additional VMs create automatically. Okay, and what will the auto scale architecture? So auto scale architecture flow will be like monitor matrices, then it goes to evaluate rules, then it goes to scale out or scale in. Okay, so auto scale add the VM instance, and scale in remove the VM instance. Okay, so now we look the next topic will design Azure app service, web app, platform as service, and application hosting. Okay, so we learned how the Azure Virtual
Okay.
Machine set provide the elastic scaling, automatic stance management, high availability, cost optimizations. However, there is a major question every Azure architect should ask: do we really need a managed server?
Need
Many
it.
organizations spend
Mm.
enormous effort managing the operating system, patching, security updates, capacity planning, and VM. But what if the business only wants to run an application? So this is where the Azure App Service become one of the
Mm.
most important compute platform in the Azure. Okay, what is the Azure App Service? So Azure form as a service PaaS offering that allow organizations to host application without managing the underlying infrastructures. And Azure manage the operating system, patching, load balancing, scaling, infrastructure availability, the custom focus on the applications code configurations, business logics. Okay, and why do we need Azure services? So compared to iTech, virtual machine iTech, which has applications, then operating system, then virtual machine, then infrastructures. Customer manage everything above the infrastructures. But in app service architecture, there is applications and then Azure app service. Azure manage the platform. Operations burden decrease dramatically. Okay.